Hi guys, welcome back to my channel Pirai Academy. In this series of Zoho interview question, today we are going to see about a question called Queen's Attack 2. So you will be given a square chessboard with one queen and number of obstacles placed on it. Determine how many squares that queen can attack. A queen is standing on an n cross n chessboard. The chessboard's row are numbered from 1 to n, going from bottom to top. Its columns are numbered from 1 to n, going from left to right. So it is not mandatory also. Okay, so this is also a valid solution. Okay, anyhow you will be getting the exact answer whether you are going from left to right or right to left, whatever you will be getting the right answer. So that's why I am going to explain you like this only. Okay, so let us go and just read the remaining question. So each square is referred by a tuple R comma C, describing the row R and column C where the square is located. The queen is standing at position RQ and CQ. In a single move, she can attack any squares in any of these 8 directions: left, right, up, down, and the 4 diagonals. So that's what the queen's move, right? In the given below diagram, the green circles denotes all the cells the queen can attack from 4, 4. So see here, the queen is standing at 4, 4 and it can be attacking in diagonal ways. So it is this diagonal, this upper diagonal is called upper right, and this is what top left, or this is top right, this is top left, this is bottom left, and this is bottom right, and this is top, this is bottom, and this is left, and this is right. Simple, right? So here we want to tell them what are all the cells the queen can attack, right? So let me explain here. See here, your queen is at what, 4, 3 here, right? And the obstacles that are these 3 are the obstacles. Now if I ask you what are all the cells the queen can move, you will be telling me that it will be moving in direction first of all. So at the top level, it can move here, this 3, here, and here. So it can be moving to this 3 cells, but here there's obstacles. That's why it is not moving. Okay, that's why it will be moving to the only one step at top. At left also similarly it cannot move because the immediate next is the obstacles. Okay, while in the right side it can be moving, while in the top right diagonal it can be moving, while the top left diagonal it can be moving, while the bottom left and bottom right and bottom, so it can be moved freely because there is no more obstacles. So listen this carefully. This obstacles is not affecting anything, right? Because it is not in the way of the queen. Hope you understand this. So if I just count how many cells the queen can attack, it will be output of 10. Okay, fine. Now what will be the brute force approach, or what will be the first approach that comes into my mind? Okay, I already know what are all the 8 directions the queen will be moving. Okay, and I will be just traversing through those 8 directions, and whenever I am encountering obstacles at my path while traversing in any direction, any one of these 8 directions, then I will be stopping there. Up to that I will be taking my result, and at last I will be returning my result. That's it. So this is going to be my brute force approach. Can you understand this? Yes. So for example, what I mean to tell is, let me take this cell again. So this is going to be my chessboard, right? 5 cross 5 chessboard. Now first of all I am going to traverse in the top. So initially I am here, right? So I will be going plus 1 step, then plus 1 step, but here it is what? It is obstacles. So I should be stopping here. So my result will be as of now 1. Okay, now here it can be let me finish in the 4 normal direction. Okay, now I can go to the left, but immediately there is what? Obstacles. So I don't want to add anything. then I can go to the right. So 1 and 2. So 1 plus 2, which is equal to 3. Okay, now I can go down. Yes. Again, no, because I'm going apart from the chessboard. Okay, that's what I mean here also. Here also you can go only 2 steps. Here also you can go only 1 step, right? So here it will be what? 4. Okay, now I can go top left diagonal. So if I go to the top left diagonal, it will be 1, then 2. Okay, so it will be 6, and then to the top right diagonal, then it will be 1, 2. So it will be 8. Now I can go to the bottom left diagonal. So it will be 9, and I can go to the bottom right diagonal. So it is going to be 10. Any other direction the queen can go? No. So total of 10 is my result. Okay. Now how I can go to the top? Okay. Just listen this. If I want to go to the top, my column won't change, but my row changes. Yes. So when I am going to the top, I want to just subtract 1 from my row, so that I will be traversing towards the top. Okay. Now how I am going to the right side? If I want to go to the right side, my row won't be changed, but my column will be incremented by 1. If I want to go to the left side, it will be ulta, like column minus 1. If I want to go to the up, okay, sorry, bottom. I already told you up, right? Now it's time for the bottom. If I want to go for the bottom, it will be row plus 1. That's it. So these are the 4 things for the main direction. Now, if I want to go to the diagonals, first of all, top left. How I can go to the top left diagonal? So see here it is what? 4, 3. When I'm going here, it is what? 3, 2. Again, when I'm going upward, it is 2, 1. So it is like row minus 1 and column minus 1. Just stay with me. This question is absolutely easy, okay? But it is looking quite hard. But when you are just working it out by using these kinds of logic, it will be so simple. Okay. Now, what is the thing? If I want to traverse to the top right, towards the top right, see here, the row will be decremented, but my column will be incremented. Can you understand this? So row will be decremented and my column will be incremented. Okay. Now, bottom left. If I want to go to the bottom left, then my row will be incremented, but my column will be decremented. So increment my row by 1, but decrement my column by 1. Okay. Now it is bottom right. Then increment my row by 1 and increment my column by 1. That's it. So this is going to be my diagonal directions. Hope you understand this. Okay. So this is going to be my brute force approach, and my brute force approach will be of time complexity of O of n, because I am going up to the 8 directions, right? So it is going to be of O of n approximately. And what is my space complexity? Here it will be O of n log of k. Okay, it will be log of k, or it may be like n plus k log k. Now what is the space complexity? It will be O of k. So this is going to be my time and space complexity analysis. You may ask why we are adding this k log k, because we are also using a set data structure. Okay, why? Because we want to just know where these obstacles are there. Okay, so first of all, I will be making these obstacles into my hash set, and whenever I am traversing in these 8 directions, I want to continuously check whether at that particular cell whether there is any obstacles. If there is any obstacles, I want to stop. If not, I want to proceed. Okay, that's why my time complexity will be something looking like this approximately. Okay, if you know the exact time complexity, please mention in the comment section, because I am not sure about this approximate, right? Fine. Now, how we can optimize this solution without using this set data structure? So here we are taking the main subject as what? Main subject is the queen. Instead of taking the queen as our main subject, if I take the obstacles as my main subject, then the set will be disappeared, right? This set is there because I want to store the obstacles and I want to retrieve or find whether that obstacle is present at that particular cell or not. If I get rid of these obstacles, then my set data structure will be disappeared and my time and space complexity will be more efficient. So what is going to be my optimized approach? My optimized approach is basically going to be like obstacles based. So it will be going to be obstacle based. What is meant by obstacle based? So let me take this another time and explain you clearly now. So just listen this carefully because this is going to be way trickier than the previous example or previous approach, because the previous approach is basic brute force approach that can be done by everyone. But this approach should be way optimized, and this approach is way difficult also because of its trickiness. In your interview point of view, okay, in your interview point of view, whenever you are just cracking these kinds of problems, then you want to just go with the optimized version. So when you are going for this optimized version, you want to think in the way like I am teaching this as a logic. Okay, just listen to this carefully. So initially, what are all the obstacles I am having here? I am having the obstacles like 2, 3. First obstacles. What's the second obstacles? It is 4, 2. What's the third obstacles? It is 5, 5. Okay. Now I'm just going to traverse through these obstacles instead of I'm going to the 8 directions from the queen. Can you understand this? Okay. So initially I want to calculate what is the minimum possibility. I can go to the top, to the right, to the left, to the bottom, and all the diagonals. I mean like just get rid of these things. Let me just erase this. Just get rid of these obstacles. Okay, just assume there is no obstacles in our chessboard. Then where are all I can go with this queen? Okay, let me fill here. So where all I can traverse by using this queen? I can traverse here, and here, and here. So these are the 4 basic directions, and I am going for the diagonal also, right? So I can go here and here. I can go here and here. I can go here. I can go here. So these are the total possibilities I can go with this queen, right? So initially I want to calculate this and store in my separate variables. Like for example, first of all, top. How much I can go up to the top? So see here, the current row value is what? 4. The current row value is 4. Then I can go up to what? 3 cells. I can go up to what? 3 cells. So which means top will be going to be row minus 1. Can you understand this? Yes. Now what is going to be my bottom? So my bottom initially going to be, I am at row number 4, and what is my n value? N value is 5. Okay, so n minus row. Can you understand this? See here, it is not starting from 0. That's why I am just altering my calculation. Just listen this carefully. It is more important. I am just mentioning this again and again. Okay, now to the left side. For the left side, okay, I want to calculate for the see here, always remember, whenever we are just calculating these kinds of calculations, then always remember we want to take the variable things. Like if the row varies, then we want to concentrate on row. If the column varies, we want to concentrate on column. If both are varies, we want to concentrate on them. So whenever I am moving to the left and right, my column will be varies. Whenever I am moving to the top and down, my row will be varies. Okay, so now I want to take care of this 3. Take care of this 3. Okay, now take the care of this 3. Now from this 3 to the left side. So 3 minus 1 will be of 2, right? So it will be like column minus 1. Simple. Okay, and what will be my right side? So right side will be, so here 3 and here 5. So here I have 2 things, right? So it will be n minus my column. Can you understand this? So this is going to be my basic 4 direction. Now it's going to be my diagonal. You may think this diagonal is tricky, but no, this diagonal is easy. Let me first you calculate this 4 things, then this diagonal will be so simple. See here. First of all, we can take whatever top left. We can go with top left. There are totally of what? Totally of this one and this one. So totally of 2, right? 2. So top left means what is meant by top left? Top left. So top left means I want to move to the -1 and -1. So I will be just moving along this diagonal. So which is common to top and left. So I want to take the minimum among the top or left. Can you understand this? So minimum of top and left. So this is going to be my top left. You can see here. You can observe here. So here there are totally 2 in the left side, but here there are totally 3. So this is minimum. 2 is minimum. So I will be replacing this as 2. Okay. Now top right. So if it is top right, then it will be minimum of just top and right. Now bottom left. If it is bottom left, it will be something like minimum among the bottom, okay, and left side. So similarly, bottom right going to be what? Minimum among bottom and the right. That's it. So this is going to be my all 8 directions initial length if there is no obstacles. Hope you understand this. Now comes the twist. Now we are just encountering the obstacles. So initially the first obstacles is 2, 3. So it will be something lying at this 2, this 3. So the obstacles will be something lying here. So when my obstacle is lying here, I can tell you that this will be cancelled out and this also will be cancelled out. So it will be ending with 1. But how we can do that in our practical way? Okay, first of all, we want to just make sure the current obstacles, either it is in top or left or in right or bottom or top left or in any diagonals. Okay, so to know about this, to know about the current obstacles direction, then we can go with the row and column relationship. Okay, fine. So that I already told you here itself. Okay, so whenever the obstacles row and the queen's row are same, then there are 2 types. Either it will be top or it will be bottom. So let me write here. If the row of queen and the obstacles are same, so row is same, okay, then if it can be of top or it can be of down, how we can differentiate it? If column is same, if the column is same, then it is either of top or bottom. Okay, what is the reason for the top? If the queen's row is greater than the obstacles row, okay, then I can tell you that it is at top. What is the procedure for the bottom? If the row of queen is greater than the row of the obstacles, less than the row of obstacles, then I can tell you that the obstacles in the bottom. Okay, similarly, if the row are same, then there are 2 conditions, whether it can be a left or it can be a right. Okay, when it can be a left, if the column of queen is greater than the column of obstacles. Similarly here, the column of queen is less than the column of obstacles. Hope you understand this. Yes, so these are the conditions for the normal directions. But for the diagonals, coming to the diagonals, how we can find it? Okay, for the diagonal, first of all, we want to find whether the obstacles is in the diagonal, right? See here, sometimes the obstacles can be here also, but it is not a diagonal, not a direction, right? So we cannot tell that it is not in these conditions, so it is definitely in the diagonal. So we want to check for the diagonal also. So how to check for the diagonal? So I can be checking like if my difference between the queen's row and the diagonals, and the obstacles row is equal to the queen's column and the obstacles column, then I can be telling you that it is a diagonal. Can you understand this? Can you understand this? See here. If I am going to the top side, then what is this? What is this? It will be like, see here, let me see here. What is this? Here the top left means it will be -1, -1 for the top left. If it is top right, then it will be -1 and +1. If it is bottom left, it will be 1, -1. If it is right, it will be 1, 1, right? So however, you will be getting the same thing in your column and row, but the signs will be different. Can you understand this? Yes. So that's why I am telling you that how we can check the diagonal is, we want to take the absolute difference between the row of queen minus the row of obstacles, which is equal to the absolute difference of column of queen minus column of obstacles. Then I can tell you that it is a diagonal. Can you understand this? Okay, now you can tell that it is a diagonal, but how you can find whether it is a top left or top right or bottom left or bottom right? So it is in a top left. Then what will be the relation? So see here, if it is top left, then my queen's row and column will be greater than the obstacles row and column. Can you understand this? Yes. If it is from the bottom right, it is from the top right, then my queen's row is greater, but my queen's column will be smaller. Let me write here itself so that it will be more good looking. So if it is top left, then my row of queen and column of queen both will be greater than the row of obstacles and column of obstacles. Okay, if it is top right, then my row of queen will be greater than the row of obstacles, but my column of queen will be always less than the column of obstacles, because it is going towards the right. Yes. Now if it is bottom left, okay, then my queen's row will be smaller than the row of the obstacles, but my queen's column will be greater than the column of the obstacles. If it is bottom right, then it will be so simple. What it means? It means my row of queen is less than the row of obstacles and column of queen is less than the column of obstacles. So these are the 4 conditions for the diagonals, right? And these are the 4 conditions for the normal direction. So by using this, I can predict that, or I can find that the current obstacles is from which direction of those of this 8. Okay, and by using this directions, I can just take whether my current step is minimum or my already initialized step is minimum. So see here, first of all, I am traversing at where? At this 5, 5, right? 5, 5. Now it is none of the direction and none of the diagonal. If I place here, it is none of the direction and none of the diagonal. So I just leave it as it is. So initially my top, bottom, left and right and all its diagonal will be of these numbers, right? To calculate these numbers, I want to do these steps. Okay, now next I am just traversing to what? To this point. So it is what? 2, 3. So it is something like here, right? 2, 3 here. So by using these conditions, all conditions, I will be just finding out it is from the top. So now listen this carefully. What is my queen's position? It is 4, 3, right? So I will be just finding what is the distance between them. What is the distance between this queen and this obstacles? So what is the distance between them? It will be 1, right? It will be 1. So now I will be taking minimum of 1, what is the top value? It is 3. What is the minimum? It is 1, right? So instead of this 3, I will be cancelling it out and making this as 1. Hope you understand this. Which means I am just making this as clear and making this also as clear. Hope you understand this. Now in the next time, if I traverse, this is what the traversing element. So it is 4, 2. 4, 2 will be something like here, right? Here. So by using the above condition, I will be finding that 4, 2 is lying in the left side. So that now my step will be like, okay, I will be calculating from the queen and the current obstacle. Okay, if I calculate, then it will be something like 0. So what is my left value? It is 2 or 0, which is minimum. 0 is minimum, right? So I'll be replacing this as 0, which implies we are just leaving this as blanks. That's it. Simple, right? Simple. Now whether any other thing is present? No. So stop here and now just add each and everything. So if I add everything, it will be 2 plus 2, 4, 5, 6, 7, 8, 9 and 10. So 10 will be my output. Okay. So it is basically like everything as calculation. Once you are seeing the code, it will be more clear. Before that, you want to try the code by yourself because it is tricky solution. Now tell me, what is the time complexity? I can tell you that time complexity will be O of k. K will be the number of obstacles. And what is my space complexity? It will be O of 1, which is a constant space. Fine. So you don't want to take this as a matrix. You can do this by using these kinds of steps. Okay, because some people will be taking this as a matrix and they will be doing that. It will be leading to the auxiliary matrix, which will be the space complexity of n square. That's why we are not taking the space and we are just traversing over this k obstacles. Fine. Now let us see the code so that it will be more clear. So always prefer a Java code for Zoho interviews. Okay. Now see here. Initially, I will be taking the top, down, left and right. I already told you how to calculate these kinds. Okay. Now again, I will be taking the top left, top right, bottom left and bottom right. Now I am going to iterate over the obstacles. Okay, and I am taking the obstacles row as I and obstacles column as J. Now at first step, I want to check whether my I is equal to the X, which means my row are equal. But my column is changing. That condition. What changing? I means the obstacles column. Obstacles column is greater than the queen's column. Then I want to move to the right side. Okay. Then I will be calculating by using this formula. I have mentioned you in the drawing explanation itself. Similarly for the left side also. Similarly for the down and for top. Then at last I want to check for the diagonal. This is the check for the diagonal. Okay. I have shown in the drawing explanation itself. Now I want to take for the top left. If I found out that it is a top left, then I want to just take the minimum value among the recent top left by using the obstacles to the already existing top left. Why I am telling you? Because sometimes in our edge case, it is something looking like, let me take this. Okay, initially like this. Okay, now at first you will be encountering 2, 3. So here you will be placing your obstacles. Here you will be placing the obstacles. But in the meantime, in your later you can encounter 1, 3. 1, 3 means the obstacles is here. But anyhow, these two cells are blocked. But in our actual calculation, it will be forgetting this obstacles. That's why we are taking the minimum among them. If I don't take this obstacle, then what will be my result? It will be 2. Whether 2 is minimum or 1 is minimum. That's why 1 is preserved as the top. Hope you understand this. Yes, I will be telling you, kindly dry run this. code, okay, so that you can clearly understand this. Now it is for top right, then bottom left and bottom right, okay, and at last I will be adding each and everything and I will be returning it. Let me submit it. Yes, it is submitted successfully. To know about these kinds of algorithm, just go and search in my YouTube channel, and if you really like this video and subscribe to my channel. Don't skip any videos in this playlist because all videos will be useful once you are appearing for the Zoho interviews. Thank you.